Now I'll demonstrate you the experiment. Characterize the Lvdt, that is linear variable differential transducer. Now in this transducer you will have to first configure the setup, in which you'll have to place certain components to their locations like primary coil, armature and secondary coil. After completing this, you will have to select here how many number of turns you need in primary and secondary, that is 1000 turns. That means on primary there are 1000 turns, and on secondary 500 secondary 1 and 500 secondary 2 turns. Select the supply voltage. Suppose I have selected 7 volt, and select the frequency of excitation of this source. For example, I have done it for 1000 hertz. That means 1 kilohertz. So the system is configured. Now once the system is configured, the core is kept at center, indicating that the voltage induced in secondary 1 is equal to secondary 2. Hence the effective or the output voltage V out would be equal to 0. So secondary is not seen, only primary voltage is being seen. Now using these cursors or controls, you can change the positions of the sensors as you are changing in CRO. Now I wish that I should change this core towards left, and I want to see what happens to the output. I go on changing, you will find the graph will show how much you have changed, and this will show you how the secondary voltage is increasing. So I go on doing this, you will find that as I move the secondary coil towards negative direction, the voltage will go on increasing. Now if I move this towards plus or towards right, then you will find two things. At center the voltage would be minimum, and look at the phase shift here. The moment I change this, you will find the phase has changed, and that's the reason I go on changing the position. You will find that now it is secondary is in phase with primary. For each millimeter you can calculate what will be the output and confirm whether this voltage is matching with the voltage calculated using the formula. This is the V out formula, means the net voltage across secondary. The formula is given, all the details are given. You will have to calculate what will be V out and confirm with every millimeter change in the core, like this. So now what I will do is I can go on decreasing this, and I'll see the change which is happening in the secondary voltage. This is the experiment, and this is the sensor which can be used for measurement of displacement.